Okay, in this video I will talk about the buoyancy. So if you have a boat that is in the water, there are two forces that affects this boat. So the first force is the weight of whatever is on the boat, including the boat itself. So if you had someone here standing, their weight and everything adds to it. And this is basically the mass times the gravity. So this is your mass and this is the gravity. This is the force that will push the boat down. And the buoyant force, we say it in buoyant, this is the buoyant force that basically is the water that is displaced by the amount of boat that is in the water. And the buoyancy force is given with this equation: rho, the density of the water or the liquid, the volume, and the gravity. So this is your density, and for water it's 1 gram per centimeter cube, or 1000 kilogram per meter cube. So this is for water. I will say or here. And V is your volume, and G is the same as the gravity. So during the equilibrium, what happens is that the buoyancy force is equal to your weight. So you have rho V G, and it's equal to mg. So knowing your, so G is gonna go here, and V is your volume. Here is actually the dimensions of the boat. So from here you can actually calculate how much of the boat is in the water. So, and that's what we call waterline. So let's do a simple calculation. Let's have a structure, like a simple rectangular structure, that is in the water. So let's give some dimensions here. Let's say this is 20 centimeter, this one. I apologize for my lack of scale. Let's say the whole dimension here is 5 centimeter, and this distance here is gonna be your h that we don't know yet. And let's say the mass of the rectangular shape is 450 grams. So using the same equation, rho Vg is equal to mg. Again, we don't care about this, and rho is 1 gram per centimeter cube. Volume is your LHW, so it's your 20 centimeter times 5 centimeter times your H that we don't know, and this is going to be equal to 450 grams. That's your mass. So if you do this, that H is going to be 450 over 20 times 5 times 1. This is this 1, the density, and you calculate 4.5 centimeter. That means your boat is going to be 4.5 centimeter in the water.